Hello guys, welcome back to my channel. Myself Vikas RH. I am currently doing my engineering in SVCE college. Today's topic is about the resistivity by 4 probe technique. Resistivity by 4 probe technique. Introduction to 4 probe technique. The 4 probe technique is a method used to measure the resistivity of a material accurately. It involves passing a known current through two outer probes and measuring the voltage across two inner probes. This method eliminates errors introduced by contact resistance and lead resistance. Principle of four probe technique. The four probes are placed in a straight line on the material being tested. The two outer probes pass a constant current through the material. The two inner probes measure the voltage drop across a known length of the material. How four-probe technique works. By measuring the voltage and current, the resistance of the material can be calculated using Ohm's law. The resistance measured is the intrinsic resistivity of the material unaffected by the contact resistance. The four-probe technique is particularly useful for measuring the resistivity of thin films and semiconductors. Advantages of four-probe technique. It provides accurate and precise measurements of resistivity. It eliminates errors introduced by contact resistance and lead resistance. It can be used to measure resistivity of materials with high precision. Applications of four-probe technique. Four-probe technique is commonly used in the semiconductor industry to measure the resistivity of materials. It is used in research labs for studying the electrical properties of various materials. It is also used in quality control processes for ensuring the consistency of materials. Limitations of four-probe technique. The accuracy of the measurements can be affected by factors such as temperature variation and sample geometry. It requires precise alignment of the probes on the material being tested. It may not be suitable for materials with very low resistivity. Comparison with two-probe technique. The two-probe technique measures the resistivity of a material with two probes, which can introduce errors due to contact resistance. The four-probe technique overcomes this limitation by using four probes to eliminate contact resistance effects. The four-probe technique is considered more accurate and reliable for measuring resistivity. Factors affecting four-probe measurements. Temperature variation can affect the resistivity measurements. Sample geometry and surface condition can also impact the accuracy of the measurements. Proper calibration and alignment of the probes are essential for obtaining reliable results. Importance of calibration in four-probe technique. Calibration of the four-probe setup ensures accurate measurements of resistivity. Calibration involves checking the accuracy of the current source, voltage measurements, and probe alignment. Regular calibration helps maintain the reliability of the measurements over time. Practical consideration for four-probe technique. Care must be taken to ensure good contact between the probes and the material being tested. The current should be kept within the space operating limits of the setup to prevent damage. Proper insulation and shielding should be used to minimize external interference. Challenges in four-probe measurements. Variation in the material properties can affect the accuracy of the resistivity measurements. External electromagnetic interference can introduce errors in the measurements. Proper data analysis and interpretation are crucial for obtaining meaningful results. Recent advance in four-probe technique. Advanced automation and computerized systems have improved the efficiency and accuracy of four-probe measurements. Nanotechnology has enabled the development of miniaturized four-probe setups for measuring resistivity at the nanoscale. Integration of advanced algorithms and data processing techniques has enhanced the reliability of the measurements. Future trends in four-probe technique. Continued advancements in materials science and nanotechnology will drive further in innovation in four-probe measurements. Integration of artificial intelligence and machine learning algorithms could enhance data analysis and interpretation. The development of portable and user-friendly four-probe setups may expand the application range of these techniques. Conclusion: the four-probe technique is a powerful method for accurately measuring the resistivity of materials. It offers advantages over traditional two-probe techniques by eliminating contact resistance errors. With proper calibration and careful considerations, the four-probe technique provides reliable and precise measurements. Thank you for watching my video. Please like, share and subscribe.